You know, the term system design can sound kind of scary, right? Like a long list of complicated terms and diagrams. But what if we thought about it differently? What if we saw it as a story? The story of a simple little app that suddenly gets really, really popular, and all the challenges that come with that success. Today, we're going to follow that journey step by step and see how engineers tackle these huge problems. So let's start at the very beginning.
Believe it or not, every app, no matter how massive it is today, starts right here. You've got a user on their phone, they send a request, and it goes straight to one single server. That server has everything: the application code, the database, the whole shebang. It's simple, it's clean, and honestly, for a little while, it works just fine.
And this is the question. It's the one every successful project eventually has to answer. What happens when you go from a few hundred users to a few 100,000 or a million? Suddenly, your simple, elegant setup becomes your single biggest problem.
And that's really the first big turning point in our story. Your project is a wild success, but that success has created a brand new kind of problem. As more and more people use it, the whole system starts to slow down. That one server that used to be your hero? Yeah, it's now the bottleneck holding everything back.
So you've got a huge crowd at your digital front door. I mean, this is a fantastic problem to have, but it's a problem nonetheless. The app is getting sluggish, users are starting to complain, and sometimes it just gives up and crashes. So the very first challenge is just figuring out how to manage all this new traffic.
The problem is pretty simple when you boil it down. Your server is completely overwhelmed. It just can't keep up with all the requests pouring in. You need more power. But how exactly do you get it?
Well, when it comes down to it, you've basically got two paths you can take. As you can see here, you can either scale up, which we call vertical scaling, or you can scale out, which is known as horizontal scaling.
Okay, so vertical scaling. On the left is like just buying a bigger, badder server. A supercomputer with more CPU, more RAM. It's simple, but eventually you're going to hit a physical limit. There's only so big a server you can buy. On the right, you've got horizontal scaling. Instead of one giant machine, you just add more and more smaller ones. This is basically limitless, but it creates a new headache. How do you decide which server gets which user?
And that's where our first hero of the story comes in, the load balancer. The absolute best way to think about this thing is as a really smart traffic cop. It stands in front of all your servers and just directs the incoming traffic, making sure no single server gets buried in requests. So you can see here, users aren't talking directly to your app servers anymore. Instead, they talk to the load balancer, and it intelligently spreads their requests across your whole fleet of servers. What's really cool is it can also do health checks, so if one of your servers goes down, it just stops sending traffic there. This is how you get what we call high availability. Okay, so we've solved the crashing problem. High five! Our app can now handle tons of users in one location. But of course, with success comes, you guessed it, a new challenge. Now we have users all over the world, and people in, say, Japan are complaining that the app is slow. The problem isn't server power anymore, it's physics. It's the actual physical distance that data has to travel across the planet. So the first weapon we use to fight this lag or latency is something called caching. The idea is brilliant in its simplicity. If a lot of people keep asking for the same piece of data, why don't we just store a copy of it somewhere that's way faster and closer to the application? That way, we don't have to make that long, slow trip back to the main database every single time.
And here's where that cache actually lives in the system. It's this high-speed layer right in the middle. When the app needs data, it checks the cache first. If it's there, we call that a cache hit. Bam, it gets it back instantly. If it's not there, okay, then it goes to the slower database, grabs the data, and then saves a copy in the cache for the next time someone asks.
Caching is great, but that still doesn't solve our problem for global users, right? Well, that's where a content delivery network, or CDN, comes in. A CDN basically takes that idea of a cache and explodes it all over the planet. It's a huge network of servers that stores copies of your stuff, like images and videos, in locations all around the world.
So with a CDN, when a user in London wants to see an image from your app, they don't have to fetch it from your main server way over in New York. Nope, the CDN serves them a copy from a local server that might be just a few miles away. Honestly, this is the magic behind how services like Netflix make sure your movie streams perfectly. That movie is probably being served from a computer in your own city.
All right, let's take stock. Our app is now stable and it's fast for users everywhere. We're winning! But the growth just doesn't stop. And now we're facing the final boss, the database. A single database, no matter how powerful, can only handle so many reads and writes per second. With millions of users, it has become our new bottleneck. This visual shows the problem and the solution perfectly. On the left, one massive, struggling database. On the right, we've split that data into 3 smaller, more manageable databases, or shards. Each one holds just a piece of the total data. This is called sharding, and it's basically horizontal scaling, but for your data.
So, in short, sharding is all about breaking up one giant database into these smaller, much faster pieces. And how does it decide which data goes where? Well, the system uses a specific rule. It's called the shard key to figure it out. For example, you might decide all users from Europe go to shard 1 and all users from Asia go to shard 2. Now, dealing with this much data also forces you to make a really big choice about your database technology. On one side, you have traditional SQL databases. Think of them like perfectly organized Lego blocks. They're very structured, very rigid, and they guarantee your data is consistent. On the other side, you've got NoSQL, which is more like a bucket of Play-Doh. It's super flexible, adaptable, and generally much easier to scale out horizontally. There's no right answer, it's just a critical trade-off you have to make.
And that word, trade-off, is really at the absolute heart of advanced system design. See, our app isn't one single thing anymore. It's a distributed system with dozens of separate pieces all talking to each other over a network. And when you have a network connecting everything, things can and absolutely will go wrong. So how do you design for that?
And this brings us to what is honestly like a fundamental law of physics for these kinds of systems, the CAP theorem. It's simple, powerful, and a little bit brutal. It says you can have 3 things: consistency, availability, and partition tolerance. The catch? In the real world, when the network gets messy, you can only pick 2.
This triangle pretty much says it all. Imagine the network connection between 2 of your database servers breaks. That's a partition. So now you have a choice. Do you stop accepting new information until the connection is fixed to make sure everyone sees the same data? That's choosing consistency. Or do you let both servers keep working, even if it means their data might be slightly different for a little while? That's choosing availability. You just can't have both at the same time.
So let's just quickly break these down. Consistency means everybody, everywhere, sees the exact same, most up-to-date data at the same time. Think of your bank balance. You really want that to be consistent. Availability just means your app never goes down. It always sends a response, even if that response is with slightly old data. And partition tolerance? That's just accepting reality. The internet is messy, and connections will break. The CAP theorem forces us to decide. When that break happens, do we sacrifice consistency or do we sacrifice availability? So let's just step back and look at the journey we've been on. Our app grew, it slowed down, and we found solutions. We used load balancers to manage the crowd. We used caching and CDNs to get fast and go global. We used sharding to scale our database to handle millions of users. And finally, we learned to use the CAP theorem to make smart, deliberate trade-offs in this complex distributed world.
So there you have it. We've gone all the way from a single server to a sophisticated global application. These are the building blocks, the core principles that engineers use every single day to build the systems we all rely on. So now you have the blueprint. The only question left is, what will you build?